Most investors think that AI trade starts and ends with NVIDIA, but the deeper you go into AI, the more you realize something important. AI no longer is just a software story. It's becoming one of the largest infrastructure stories in modern technology history because behind every AI model, there are massive physical systems powering it. You got giant data centers, you got electrical grids, cooling systems, networking fabrics, fiber optics, lasers, and high bandwidth memory. And the scale is becoming enormous. Some next generation AI campuses may require gigawatts of electricity, enough power to support hundreds of thousands of homes. AI clusters are scaling towards hundreds of thousands of GPUs. Bandwidth demand is exploding. Cooling systems are becoming mission critical. And many experts now believe the next major AI bottlenecks may not be in chips at all, but the infrastructure underneath them, which means the biggest opportunities in AI may not only come from NVIDIA, but from companies powering the entire AI stack behind it. So today we're breaking down the AI infrastructure stack layer by layer to show how AI actually works physically, where the biggest bottlenecks are forming, and which parts of the ecosystem could become more increasingly important over the next decade. First, you have the hyperscalers. The hyperscalers are the demand engine. Hyperscalers spend hundreds of billions of dollars buying every layer beneath them. Then you have the data centers. They build the AI factories. They're the new industrial infrastructure. And you have networking. High performance fabrics connect the AI world. Cooling. Cooling systems remove massive amounts of heat. The optics. High speed links between systems and clusters. The photonics. The light speed data. Photonics and lasers move data at the speed of light. The memory. Memory is a limit. High bandwidth memory keeps AI moving. The chips or the brains and the GPUs and custom silicon drive the compute. Substrates and materials, advanced materials, the foundation beneath every chip. And then you got the power. It's the power of the AI revolution, gigawatts of power for AI factories, massive amounts of power and electricity. We're going to trace how AI physically works from the hyperscaler spending hundreds of billions of dollars all the way down to the infrastructure enabling the AI revolution underneath them. And by the end of this video, you may realize that NVIDIA is only one layer of a much larger story. For years, investors viewed AI mostly as software, chatbots, apps, algorithms, but the AI industry is rapidly transforming into something much larger, physical infrastructure. The world's largest technology companies are now building AI factories at a scale we've never seen before. Massive data centers, gigawatt campuses, liquid cooled server farms, AI infrastructure consuming enormous amounts of electricity. And this spending cycle may continue for years. Hyperscalers are expected to spend hundreds of billions of dollars building the next generation of AI infrastructure. At the center of it all are increasingly powerful GPU systems like NVIDIA Blackwell platform. But more compute creates new problems. Higher rack density means more heat, more power demand, more networking traffic, more memory requirements, more cooling infrastructure, which means the AI trade is rapidly expanding beyond semiconductors alone. Because every AI model ultimately depends on physical infrastructure underneath it. And that may create entirely new winner investors are only beginning to understand. Entirely new winners that investors are only beginning to understand. At the top of the AI stack sits the hyperscalers, Microsoft, Amazon, Google, and Meta. These companies are effectively funding the AI infrastructure boom. Hundreds of billions of dollars are now being poured into AI models, GPUs, networking, cloud infrastructure, optical systems, and data centers. And the competition is accelerating rapidly. For every company wants the most powerful AI models, the fastest infrastructure, and the largest infrastructure advantage, which means spending continues to rise. The hyperscalers are no longer behaving like traditional software companies. They're starting to resemble industrial infrastructure giants, and every layer underneath them benefits from this race, from power to optics to networking to memory. Every dollar spent by hyperscalers flows through the entire AI infrastructure stack. One of the biggest problems facing AI right now may not be chips, as it might be electricity. AI factories require enormous amounts of power, and as rack density rises, power demand rises with it. Some next generation AI campuses may require over 1 gigawatt of electricity. It's enough power to support hundreds of thousands of homes. That's creating pressure across the entire electrical infrastructure system. Substations, transformers, cooling systems, backup power, grid infrastructure. And many regions simply do not have enough infrastructure ready for the scale of demand. This is where companies like VRT, ETN, Eton, Vertiv, GEV, GE Vernova, and IREN enter the conversation. Meanwhile, companies building AI-focused infrastructure like IREN are attracting increasing investor attention because access to land and power may become strategic assets in the AI economy. Transformer shortages are already creating long lead times. Grid updates can take years, and cooling systems are becoming mission critical as rack power density continues climbing dramatically. No power, then you get no AI. And this could become one of the defining bottlenecks of the entire industry. As AI clusters become larger, another problem begins to emerge, and that's bandwidth. AI systems constantly move enormous amounts of data between the GPUs. And the larger these clusters become, the more important networking infrastructure becomes. This is where companies like ANET and MRVL become increasingly important because AI is no longer just a compute problem. It's increasingly a communication problem. The industry calls this east-west traffic, GPU to GPU communication inside massive AI clusters. And this traffic is exploding as clusters scale towards hundreds of thousands of GPUs. If networking cannot scale efficiently, AI performance slows. This is why the industry is rapidly shifting towards 800 gigawatt networking, 1.6 terabit networking, advanced switching fabrics, low latency architectures, because the bandwidth wall is becoming real, and many investors still underestimate how important networking infrastructure may become in the AI economy. This is where the AI story becomes even more interesting. Traditional copper connections cannot scale forever. AI workloads are becoming too large, too fast, and too power intensive, which is why the industry is increasingly shifting towards optical infrastructure, fiber optics, lasers, silicon photonics, optical internet, interconnects. Companies like Lumentum, LITE, AAOI, Applied Optoelectronics, SIVERS, SIVE, and Coherent, COHR, are all connected to different parts of this ecosystem. The industry is now transitioned towards 800G networking, 1.6 terabit networking, co-packaged optics, optical engines, photonic interconnects. Because AI may ultimately be one of the most important infrastructure shifts in the entire AI industry. The more AI scales, the more the world may move towards optics. And this could become one of the most underestimated bottlenecks of the entire stack. Why optics is critical for AI. Explosive bandwidth demand. AI clusters require exponential increases in data throughput, lower power and less heat. Optical interconnects reduce power and consumption and thermal load. Longer distances. Optics enables high-speed data movement across racks, rows, and data centers. And it's built for the future with 800G, 1.6T, and beyond. Optics is the only path forward. You can't go back to electrical with copper wiring. Higher speeds, lower power, less heat, better scalability. That's the future. But even the fastest GPU in the world is useless without memory bandwidth. And this is another reason AI infrastructure is becoming increasingly more complex. High bandwidth memory, or HBM, has become one of the most critical components in modern AI systems. That's benefiting companies like Micron, MU. HBM, high bandwidth memory, demand is expected to grow dramatically over the next several years as AI models become larger and more memory intensive. At the same time, advanced packaging technologies are becoming increasingly important because modern AI chips are no longer simple processors. They're massive interconnected systems requiring substrates, advanced interconnects, packaging layers, high speed memory integration. And many analysts believe advanced packaging capacity could become another major bottleneck in the AI boom. In other words, the AI industry may eventually be constrained not by the chip itself, but by everything connected around it. So this is the GPUs, the brains of the operation. NVIDIA makes the GPUs. These are the HBM stacks, ultra-fast memory close to the GPU for maximum bandwidth. And Micron is making the HBM, the high bandwidth memory. Interpose or high density interconnects routes billions of signals. Advanced packaging, 2.5D to 3D packaging integrates everything at unprecedented density. And the substrates is the foundation that supports power delivery and signal integrity. The AI boom may ultimately be constrained by what connects the chip, not the chip itself. GPUs compute the power. HBM's the memory bandwidth. Interconnects move the data. The packaging brings it all together. And the AI performance real world results. Why the memory matters. AI workloads are data hungry. The high bandwidth is critical. Demand is exploding as HBM is expected to grow by 3x by 2028, and supply is very tight, limited capacity, long lead times, and strategic advantage. You got companies like Micron, leading provider of HBM memory solutions for AI GPUs. Broadcom, AVGO, custom AI accelerators, advanced packaging technologies. And then you got microcaps like Onto, critical tools for advanced packaging and process innovator. So as most investors are focusing on single layers of the AI trade, it's usually NVIDIA with the GPUs, but the real AI opportunity may involve understanding the entire infrastructure stack and what's underneath it, because every layer matters. You got the power, the cooling, the networking, the optics, the photonics, the memory, the packaging, the data centers. And over the next decade, the biggest winners may not simply be the companies building AI models. They may be the companies solving the infrastructure bottlenecks powering the AI economy. The future of AI may depend on whoever solves the power constraints. Bandwidth scaling, east-west traffic growth outpacing networking limits, the optical capacity, which is the transition to light, which is complex, expensive, and capacity constrained. You got the memory bandwidth, advanced packaging. You have a limited capacity and yield challenges. Cooling density, heat densities are hitting near records. NVIDIA may be the face of AI, but the infrastructure may be the engine. And the company solving these bottlenecks may quietly become some of the most important businesses of the next decade. So for power and infrastructure, you got Vertiv, you got Eaton, you got GE Vernova, IREN, among others. And then for the networking, you got Arista and you got Marvell. And then optics and photonics, you got companies like Lumentum, AAOI, Applied Optical Electrics. You got Sivers, Coherent. And then memory, HBM, Micron, the leader in HBM memory. And you got Broadcom and Onto, among others. So which layer of the AI stack do you think becomes the biggest bottleneck over the next 5 years? Is it going to be power, bandwidth, optics, memory? Let me know in the comments below. And if you enjoy deep dives into AI infrastructure, the hidden bottlenecks and emerging technology trends, make sure to like and subscribe to the video. It really helps me out because this AI infrastructure story is only getting started. So, and also check out buymeacoffee.com membership page. I'm building a growing library of AI infrastructure visuals covering everything from opticals and photonics to networking, power infrastructure, cooling, AI factories, memory and packaging, hidden bottlenecks across the AI stack. So everything is organized in one place for members to reference anytime. The link is in the description. And as the AI infrastructure story evolves, I'll continue to keep adding new visuals, research, ecosystem breakdowns there as well. So appreciate y'all watching, and we'll see you in the next one.